Hello and welcome everyone to this lecture on the Introduction to Statistics. After today, hopefully you'll be able to describe the 5 stages of the research process, define your independent and dependent variables, distinguish between the 3 levels of measurement, and look at descriptive and inferential statistical procedures. Data and statistics are important to understand in terms of how we interact with them, both in our daily lives, in school, but also potentially in our job. Data is information represented by numbers, which can be used in or be the subject of statistical analysis. Statistics are a set of procedures used by scientists to organize, summarize, and communicate numerical information. So data, in a lot of ways, is that kind of raw material that we get from polls, from those student evaluations you do at the end of the semester, things like that, whereas statistics are the tools we use to analyze and try to make sense of that information. The research process consists of 5 main steps. The first is to ask a research question. It needs to be specific, it needs to be detailed. The next is we need to formulate the hypothesis or hypotheses that we're going to have. These are basically answers to our research question, or our educated guesses as to those answers. Next, we're going to need to collect data to see if our hypotheses are correct. We're going to analyze data. That's where that statistics comes in. And finally, we're going to use this data and the statistical analysis to see if our hypotheses are correct. And we may need to go back and reevaluate our hypotheses. We may even need to go back and reevaluate our research question as we learn more about the topic. So our first step is asking those research questions. And research questions are a specific type of questions that can be answered by what we call empirical research. This is research that is based on evidence that can be verified using observable data. So this is basically a question, a scientific question, that can be answered looking at the world around us, collecting that information, and applying it to that question. This means that research questions or scientific questions do not include moral, ethical, or theological questions. So research questions in science can't answer questions around whether something is morally right or morally wrong, whether something is ethical or not ethical, or what God is like, or if there is a God, or any of those sorts of questions. Those are not the purview of research questions. Research questions can address, for example, whether people think something is moral or ethical, whether they believe in God or not, but we can't actually answer whether God is real or not, but we can ask other people if they think that. So below here I have a couple of examples of research questions. The first is, how does educational attainment impact future income? And the next question I have is, what factors affect the promotion or hiring of female workers? Now these are fairly specific questions that again can be answered by empirical research, by going out and collecting data, observing things, doing surveys. I can answer these questions with observable data. Our next step is formulating hypotheses drawn from the theories we hold about how the world works. Hypotheses are a very specific prediction, whereas theories are a set of assumptions or propositions that we hold about the world around us. And theories are something that we may not be conscious that we hold. For example, as students here at Cal State, you probably think that education is important and that education is valuable. That is a theory you hold. And what we want to do here is take that theory and take part of it and turn it into something that is actually testable, that we can actually study and see if it's true or not. So a hypothesis in this case is a testable prediction drawn from a theory that specifies a relationship between 2 or more variables, and these variables describe a unit of analysis. So let's dig into this a little bit more. Variables are characteristics of a particular object, person, event, thing, whatever. They describe a certain characteristic about that object or event or person. That object, event, or person is what we call the unit of analysis. The unit of analysis is the focus of our study. It is the thing we are collecting data on. And the variables are representations of that data. And so a hypothesis must have at least two variables, like we stated above, and it also has to have a direction. That means it has to say that there is a relationship between these two variables and that this relationship has a directionality to it. To illustrate this, I have two hypotheses here. The first is people with higher levels of educational attainment will have higher incomes in the future. So this is based on the research question from the previous slide. And here we have two variables. We have educational attainment and we have income. Those are our two variables. We also have a direction. We're saying that higher levels of educational attainment will lead to higher incomes in the future. That is a direction. As one is getting higher, the other is getting higher. And this has caused a positive relationship. This is called a positive relationship. It's positive because as one variable moves, in this case educational attainment, the other variable, in this case income, moves in the same direction. We could completely rephrase this hypothesis as people with lower levels of educational attainment will have lower incomes in the future, and this again would also be a positive relationship because as educational attainment went down, income goes down as well. We also have something that's called a negative relationship, and this is basically a relationship between two variables where as one goes up or down, the other moves in the opposite direction. So an example of a negative relationship in this case would be when we have higher levels of educational attainment, income goes down. Or we could say as we have lower levels of educational attainment, incomes would go up. That would be a negative relationship. But that doesn't really make much sense here. In general, based on our theory that education is probably beneficial to you, we are arguing that people with higher levels of educational attainment will have higher incomes in the future. This next hypothesis I have done here, this last one, says people's educational attainment will affect their income. Now again, we have the two variables here, educational attainment and income, but we don't have a direction. We don't know if this effect is going to be positive or dictate a positive relationship, or if it's going to be a negative relationship. We don't know the direction. So it's important to have that directionality to your hypothesis. Alright, so let's dig a little bit more into those variables. There are two main types of variables we're going to look at today. The first is independent and the second is dependent variables. So let's start with dependent variables, are variables that we are trying to explain. Independent variables are the variables that we think will do the explaining. In other words, dependent variables are the effect, whereas independent variables are the cause. So we're thinking that independent variables are going to cause some sort of change or effect to that dependent variable. In order to show that the independent variable is causing some change to the dependent variable, in order to show what we call causality, we need to demonstrate three separate things. The first is we need the independent variable, or cause again, comes before the dependent variable. So what this means is that the independent variable, or cause, has to occur in time before the dependent variable, or the effect, right? And so if we think about this, this makes a lot of sense, right? We can't have a cause come after an effect in time. We also have to show that there is a empirical relationship between the cause and effect, such that a change in our cause or a change in our independent variable causes some sort of change to our effect or our dependent variable. We need to see that relationship. And on top of that, we need to show that this relationship that we're seeing between our independent variable and dependent variable cannot be explained by other factors or variables. So let's go back to our educational attainment example and its effect on income. We hypothesized that educational attainment and increased levels of educational attainment will cause an increase in income. In this case, educational attainment is our independent variable because we are arguing that it will cause some sort of change to our dependent variable, income. So we have our independent and dependent variable. Our next step would be to show that yes, indeed, when we have someone with more years of education, that does cause their income to go up. And then we also have to roll out a lot of other competing factors, right? So other things may cause changes in income, right? Race, gender, occupation, things like that may impact income and are not necessarily related to educational attainment. So we'd have to rule out those factors as well. So once we've decided on our research question, hypothesis, and variables, we can actually start that data collection process. First, we have to decide how we will measure the data. For example, if our research question is, how does educational attainment impact future income? We will need to decide how we will measure both educational attainment and income. And this is particularly tricky with educational attainment because educational attainment is fairly vague. You may not initially think so, but as we dig into it, how are we going to measure this? Are we going to measure it in terms of your grades, whether you got A's, B's, or C's? We can measure it in terms of GPA. We can measure it in number of years you've been in school. We could also measure it as highest degree completed, whether you got a high school diploma, an associate's degree, a bachelor's degree, master's degree, doctorate. Sure, we can measure it that way. We could also measure it, say, the number of college units you've completed successfully, etc. So we're going to have to pick a way to measure it. Otherwise, it's too vague. Income's a little simpler. We can just say your yearly income or your monthly income or your weekly income. But we still need to specify what we mean by income there. Whether we're going to take it for the year, for the month, for the week, etc. Step in kind of setting up our variables here is to figure out the level of measurement we're going to have. Now, we're going to start with nominal level measurement. And this is categorical information. So information that's purely categorical, there is no ranking to this system, no order to it. So it could be things like your eye color, your hair color, your skin color, race, gender, things like that, where there are simply categories with no inherent order or ranking to them. Ordinal level measurement, on the other hand, is categorical, but it does have that ranking or order to it. So an example of this would be a level of satisfaction survey, right? From most satisfied to least satisfied, or most satisfied to most dissatisfied, however you want to phrase it. Could also be things like your position in a race, or who got first in a game, things like that. Those would be ordinal. Next we have interval level measurement. And again, it takes a lot from ordinal level measurement in that it is, again, categories, but this time those categories have an order and has equal intervals between variables. With ordinal level measurement, we did not have equal interval between variables or between measures. And that is to say that what is the difference between very satisfied and somewhat satisfied? We can't really put a numerical value on that. However, with things like temperature, if it's 30 degrees outside and someone else is saying, okay, well now it's 32 degrees, we know that that is a 2-degree difference. And that ability to say it is a 2-degree difference is something that interval level variables have, or interval level measures have, that ordinal level measures do not. However, interval level measurement does not have a true zero. That is only for ratio level measurements. And your book fairly much equates interval ratio level measurements as being the same, and you can do that for the most part. It really isn't an issue. But it is important to know that interval level measurements do not have a true zero. And because you do not have a true zero, you cannot use ratios, you cannot multiply or divide interval level measurements. And again, temperature is a good example of this. If it is 0 degrees outside, that does not mean that there is an absence of temperature. It does not signify the absence of something. With ratio level measurements, if I said I have 0 money, it would indicate the absence of money. And so that is the difference between interval and ratio level measurements. Interval do not have a true 0 point, whereas ratio does have a true 0 point, where 0 signifies the absence of something. Here are some other ways we can categorize measurement. We can have what are called dichotomous measurement, which is measurement that only has two categories. So when we have a variable that is simple yes or no. Did you pee in the pool? Yes or no, right? That's a silly example, but that's the sort of idea. There's only two answers you can give. We can, a lot of times in sociology, we use different dichotomous variables about white versus non-white individuals, college graduates versus not college graduates, etc. We also have variables that are considered discrete measurements, or measurements with a minimum unit size. So an example of this would be number of children. I personally can't have 1.23 children. I either have 1 or 2 or 3 children, etc. You can't have a fractional child. And then lastly, we have continuous measurements, which are measurements with no minimum unit size. So think length, percentage of women in the workforce. Those can all be described in decimal or fractional values, and so there is no minimal unit size or minimum sized unit. Now these types of measurement are laid on top of the measurements we talked about earlier: nominal, ordinal, interval, and ratio. So these go on top of that. They are not separate from. And so we might have a nominal dichotomous measurement, and we could have a discrete interval or ratio or ordinal level measurement, as well as a continuous interval or ratio level measurement as well. So our next step is to actually go out and collect that data. Again, the first thing we need to do here is we need to decide what our population of interest is. So this is the overall group that we are interested in getting information about. The next step then is to sample from that population using sampling. And what this means is taking a smaller portion of that population and using that to represent the overall population. So an example of this would be if my population, say, is students at Cal State Long Beach or Cal State Fullerton, then I could go and ask every student at Cal State Long Beach or Cal State Fullerton, but that is probably going to be very onerous. Instead, I am more likely to take a sample and use sampling. And there I'm going to take a smaller fraction of the students, say at Cal State Fullerton, and use that to represent the overall population of students at Cal State Fullerton. So rather than trying to get information about all, tens of thousands of students at Fullerton, I instead may ask only 500 students at Cal State Fullerton and use those to represent the entire population. And so the population then is this total set of individuals, objects, groups, events, etc. that we're interested in, whereas sampling is the process of identifying and selecting whatever subset of that population we are actually going to get data from. And this smaller subset is what we call the sample. Next we have our data analysis. And data analysis is either descriptive or inferential. Descriptive statistics generally help us organize and describe the data we have collected. So it typically will include things like your mean, median, mode. Those are measures of spread of center, but also measures of spread. So measures of spread would be like your variance, your range, minimum, maximum, things like that. And so this is where we just get kind of a general idea of that information. So what is, for example, what might be the mean educational attainment? What is the mode educational attainment? What is the median educational attainment? Same thing with income. How far apart, what is the range on this income? What is the minimum, the maximum? How much variation is there within income? Those are the sorts of things we can get with our descriptive statistics. Inferential statistics, on the other hand, allow us to make a prediction or an inference about the population from our sample. So maybe we find out that from our sample that people, again, with more education tend to have higher incomes. We can then use that information from our sample to make an inference or a prediction that in our general population, whatever our population is, that educational attainment will predict future income, so that people with higher educational attainment will have higher incomes in the future. That would be a prediction or an inference using what we call inferential statistics. Finally, we need to evaluate our hypotheses. So after we've kind of done our descriptive and inferential statistics, we can then decide whether or not to accept or reject our hypotheses. This isn't always as clear-cut as this sort of kind of outline would make it seem. Sometimes we get partway through and we realize that we have strange data, or that some new questions are raised in the analysis or collection of the data, and we return to step one and start all over with a new question, or set of questions even. Sometimes we realize that our hypotheses are wrong and we need to reconsider our theory, and so we go back and look at new theories, we come up with new questions and hypotheses, and start over again. Sometimes we might confirm or reject our hypotheses, and this even opens up new avenues of research that we hadn't thought of before. So none of this is particularly close-ended. It's very open-ended with a lot of complications, starting over, reviewing things, re-looking at things with fresh eyes, that sort of thing. Alright, that's it for this lecture. Thank you all. Hope you have a good day, and I'll talk to you next time.